Okay, in the previous two videos, we have seen about thermodynamic process, isothermal process, isochoric process, and isobaric process. Here we will study about adiabatic process. Adiabatic process is the process that takes place when there is no heat exchange between the system and the surrounding. If this is our system and the surrounding, so if there is no heat exchange between the system and the surrounding, the process is said to be adiabatic process. If there is no heat from the system to the surrounding, or vice versa, if there is no heat exchange, the process is said to be adiabatic process. Adiabatic process. Therefore, it takes place when change in Q is equals to 0. Change in Q is equals to 0 means there is no change of heat in the system. If there is no heat exchange between the system and the surrounding, change in Q is equals to 0. So adiabatic process takes place when change in Q is equals to 0. To show adiabatic process graphically, let's first show the equations of adiabatic process. The equations of adiabatic process is given as PV raised to gamma is equals to constant. Where gamma is greater than 1. Now PV raised to gamma is equals to constant. From this PV raised to gamma is equals to constant. Let's say instead of constant, substitute by capital C. So P is equals to C over V raised to gamma. Pressure is inversely proportional to V raised to gamma. In isothermal process, pressure is inversely proportional to V simply. So the graph which represents this equation is given as, if this is P and this is V, pressure is inversely proportional to V raised to gamma. This is the graph of adiabatic process. Now, when pressure decreases, volume becomes increased. The volume of the gas increases. When volume becomes decreased, pressure becomes increased. Inversely proportional. Now, the first law of thermodynamics in adiabatic process is given as change in Q is equals to change in U plus change in work done. This is first law of thermodynamics. Since change in Q is 0 in adiabatic process, there is no heat exchange between the system and the surrounding. Change in Q will be 0. So 0 is equals to change in U plus change in work done. From this, we have change in internal energy of the gas equals to minus change in work done. This is first law of thermodynamics in adiabatic process. Since change in Q is equals to 0, when we substitute 0 instead of changing Q, the first law of thermodynamics in adiabatic process looks like this. The other point is work done in adiabatic process. Work in adiabatic process. Now, change in work done is equals to pressure times change in volume. Pressure times change in volume. Change in. Let this change in can be substituted by the derivative of work done is equals to pressure times the derivative of volume. Change in volume is equal to derivative of volume. Change in small value of volume. So here the area under this graph, let's say this is V1 and this is V2. The area under this graph is equal to the work done, equal to the work done. Now, a small PDV, small amount of PDV. The summation of a small amount of PDV is equals to the total work done. So, to do this, if we integrate both sides of this equation, this implies as integration of d of work done is equals to integration of P dV, where dV varies from, volume varies from V1 to V2, from V1 to V2. We sum the value of P dVs from V1 to V2. The work is done between these two volumes. Therefore, the integration of dx is equals to x. In similar way, the integration of d of work done, integration of hence integration of d of work done is equals to work done, which is equals to integration of from V1 to V2 P dV. Now, work done is equals to integration from V1 to V2 P times dV. That pressure is equals to pressure times V raised to gamma is equals to constant, already discussed. From this we have pressure is equals to C over V raised to gamma. Substitute C over V raised to gamma instead of pressure. Therefore, work done is equals to integration from V1 to V2 C over V raised to gamma times dV. So C is constant. Take C from the integration outward. So this is equal to C V1 to V2 dV over V. Therefore, work done is equals to V raised to gamma. This is V raised to gamma. C times V raised to gamma. Okay, here one step is left. Integration of V1 to V2 V raised to minus gamma dV. dV over V raised to gamma, V raised to minus gamma. 1 over V raised to gamma is equal to V raised to minus gamma. V raised to minus gamma. So the integration of V raised to minus gamma dV is given as C V raised to minus gamma plus 1 over minus gamma plus 1 when V varies from V1 to V2. V1 to V2. So this is equal to C into V2 raised to minus gamma plus 1 minus V1 raised to minus gamma plus 1. Here minus gamma plus 1. This term. Now, work done in adiabatic process is given as work done in adiabatic process W in adiabatic process equals to C V2 raised to minus gamma plus 1 over minus gamma plus 1 minus C V1 raised to minus gamma plus 1 over minus gamma plus 1. But P1 V1 raised to gamma P simply let's say PV raised to gamma is equals to constant, or C means P1 V1 raised to gamma is equals to P2 V2 raised to gamma is equals to C. Therefore, P1 V1 raised to gamma is equals to C. P2 V2 raised to gamma is equals to C. Therefore, it is possible to substitute P1 V1 raised to gamma instead of C and P2 V2 raised to gamma instead of C. Therefore, work done is equals to P2 V2 raised to gamma substituted here times V2 minus gamma plus 1 over minus gamma plus 1 minus P1 V1 raised to gamma times V1 minus gamma plus 1 over minus 1 plus minus gamma plus 1. Multiply this P2 V2 raised to gamma, V2 raised to minus gamma plus 1. V2 base, the base are the same, therefore this is positive gamma, this is my negative gamma, minus gamma. Therefore, P2 simply V2 gamma minus gamma 0. Here 1 V raised to 1 is simply V2 raised to 1 means V2 minus P1 V1. Here V1 the same base, gamma minus gamma over minus gamma plus 1 is equals to work done. This is work done in adiabatic process. Work done in adiabatic process. Simply, adiabatic process is a thermodynamic process that takes place when there is no heat exchange between the system and the surrounding. Heat exchange. No heat exchange means change in Q is equals to 0. If change in Q is equals to 0, the first law of thermodynamics is written as change in U is equals to minus change in work done, minus change in work done. This is the first law of thermodynamics in adiabatic process. So, in adiabatic process, the graphical representation of adiabatic process is different from the graphical representation of isothermal process. The graph of adiabatic process is steeper than the graph of isothermal process. The graph of isothermal process.